for waiting until Mr. George joined. So good evening, everyone. Once again, you are all welcome to another section of our data structures and algorithm. Yeah. So to not to waste much time, I'll be ushering in Mr. George to take the session. Okay, Mr. George, please, you have the floor. Thank you.
Yeah, I'm sorry for coming late. I just from doing something quickly, and then I decided to come up on the call, and I'm trying to prepare. So I beg you, forgive me. Let me try and show the slide. Okay. So today we're going to talk about HashMap. We're going to talk about HashMap, and in our presentation today. One second. So in our presentation today, we will be looking at HashMap. I actually got this slide from a class I was doing back in those days. They gave us this slide relating to HashMap. It's popular, it's on the internet, anyone can access it. But I just did a few modifications to it. It is I think Stanford lecture 2019 slide around HashMap. Sarah Good and Laura Cruz, I bet he was the people that was teaching at the time. I don't know who's teaching there now, but these are the people that are offering at Stanford. So this is like a slide from Stanford. And today we want to go into the nature of HashMap. How can we use it? How it is supposed to be used, and all of those things that we need to talk about. So without wasting time, we will get to it. The goal for today is to look directly at HashMap. That is the goal. So you can know how a HashMap is. Maybe we will do some coding here and there, but this is the primary goal. And I will just, if you don't have an editor, what you can do is you can go to LeetCode. You can go to LeetCode. Yeah, on LeetCode you can get a playground where you can come here and then you can get a Java playground. That is what I'm going to do. I'm gonna get a new playground. And then what you can do with this playground, for me, I'll just, because I want to keep looking at the playground while I focus on the slide. Okay, good. So I'll try to make this bigger so you can see it. But this is how you can get a playground. Just in case we have it to code, I will use the playground. So I can remove it from C++ to Java. Okay. So in today's we'll be looking at HashMap. Few of the things we want to talk about. We want to talk about HashMap, key setting, a dictionary, counting words, swapping keys. These are all examples that are already in this slide, and you can try and go and build them on your own. But our focus will be, what is a HashMap? A HashMap, before we go to it, I will talk about previous thing I think you people have already covered. That is string. That is another string for array list. So what is an array list? An array list is a dynamically sizing list. That is to say that it's a type of list that is used to store a lot of elements. So take for instance, in your previous DSA session, you might have covered that in an array list you can store series of elements. Almost as an array, you can store them like this. Because the size of an array is fixed in Java. For what an array list allows us to do is it allows us to dynamically allocate space for array as the array increase. So if you want to store an array that you don't know the size of that array at compile time, what you could do, you could use an array. I mean, at runtime, what you could do, you could use an array list. So, but with the problem with an array list is that in an array list, you are always storing one data type. So if you are storing integer, you are storing only integer. So, and also if you want to find a value in an array list, it becomes very challenging. It is usually work in operation. So this is why HashMap was created. Now, what is a HashMap? A HashMap is very simple to understand. In a nutshell, a HashMap is just like a key value. Say for instance, you have a store, and then you have a series of shops. Maybe you have a lot of shops. So you have shop 1, shop 2, shop 3. And all of these shops, you have key for them, right? If you are in Nigeria, you probably know about working for, I think the Igbos. The Igbos are the ones who usually are involved in business. So you already know that they have series of shops, and then sometimes they have like a boy they take who will be settled later on to take care of those shops. So for instance, you are a business person and you have about 5 shops, and all of these 5 shops, you have individual key for them. Let me try and open Escala Drawer to make it more visual. So all of these individual shops, you have keys for them. And whenever you go to that store, a specific shop, you use the key, you open, you get what you want to get. This is how HashMap works. If you ever use a JSON in JavaScript, if you ever use a JSON in any of your REST API, you can also look at it as a HashMap, because it is just key and a value. You have key and you have a value. So take for instance, let me come here and just like show you something. Let's try to show you an example. So okay, so here you see we have a key and we have a value. We have key and then it's pointing to this. So this is how HashMap typically works. You have key, you have value, you have key, you have value. So if I want to access sales, sales card, I will use this. So that is the general idea there. We might get into some complexity, but I just want you to picture it like this. This is the general idea. You have key, you have value. That is just how our HashMap works. So that is how our HashMap works. So if you have a key, you put that key in, you will have a value out. That is the idea of a HashMap. So the next thing we want to talk about is creating your first HashMap. Now, whenever you are creating a HashMap, you firstly have to determine the type of key, which is the data type of the key, and then the value of that key. You have to do all of those when you are creating a HashMap. So take for instance, if I'm to create this HashMap here like this, firstly let me try import everything on Java. One is cool. So if we are creating a HashMap, what we are saying is in here, in this area, you have to pass in the value. You have to pass in the value of the key. So take for an instance, if you're saying that what you'll be passing in will be, let us pass in the capital city, right? So what we want to do, we want to say we are passing in screen for both the key and the value. So maybe we can call this a country map, and this is equal to a new hash map. Permit me to expand this a little bit. So this is equal to a new hash map. If you already, another thing, if you already specify what you'll be putting, the screen, if you have already specified these two data types, there is no need to specify here. Java will automatically know what you are talking about. So the next thing we want to do is, if I want to put a country in my hash map now, what I will do in my country map, sorry, and we'll talk about this shortly. I will put Nigeria. I think it's Abuja, something like that. So now this is how you put you add an element, you put a value in the hash map. Now the idea is that whenever you put a value in the hash map, these values they will be generated with the hash function. And the role of the hash function is to make sure that every key has a unique pointer to a value. Two keys cannot have the same pointer. We will get to them. So what I'm saying is this. If you have a hash map, like this, and you have, this is a key, and this is a value. And now you put a key, Nigeria as a key. Nigeria will get mapped to Abuja. But before this mapping can happen, there will be a hash function, there will be a hashing. Because if you have ever used, if you are ever logging, if you ever do anything with logging in as a authentication system, what you realize is that in the database, we are not saving your password. We are saving hashes of your password. So we are saving hashes of your password in bcrypt. So if whenever you put a key in Nigeria, you will have this hash. Maybe this could be random numbers, and this hash will point to the key to the value Abuja. This is what we are talking about. This is what we are talking about. So when we are saying a key will always have will always point to a value, that's just like what we are talking about. You have a key and you have a value. So that is just the general idea of a hash map. We will return back to this. So without wasting time, we move to our next. So this is the data type, as you can see on the slide. This is the data type of the key. The first parameter is the data type of the key. The second parameter is the data type of the value. So if you come here, the second parameter is the data type of the value. So you have key, you have value. These are the two things that we are storing. In our example, if you look on the side, you see we have even go as far as specifying the key here. Well, if you do this, it's okay. But for example, for most of the things we'll be coding, we don't really have to follow the standard notation like this. So now repeated types of key value. So you are repeating the types. This is what we are saying. You are not forced to do it. In modern Java, you are not forced to repeat the type. But I think in Java 8, you have to repeat the types. But in modern Java, you don't need to do this. So this is just what we are saying. Like you can shortcut it like this. Like what I was telling you, you can shortcut it like this. So if you are coding along in this session, you can go ahead and create your first hash map using this notation. Now, the next thing we are going to talk about is, they just put few things. For me, I put countries and other stuff in my hash map, but you can put whatever you want in your map. It's okay. So I'll skip all of this. These are just repetitive stuff. Now, to get a value from our map, there's a way we can get a value from our map. We can be able to get a value from our map using the get method. And the get method allows you to access a value based on a key. So take for an instance, in our map, we have hundreds of port Nigeria point to Abuja. So what we will try to do is we will try to get it. We will try to firstly put this country in a variable called capital city. And then what we will try to do is the country get. And then we will pass in Nigeria here. And if you pass in Nigeria here, what you will see is that it will do a system. It will say capital city. What we get is let me see the error. You're not found simple. I'm sorry. This should be content back. Okay, so when we run our code, you see we have Abuja, right? So this is what we are saying. You can use the get to return a value. Don't go making table like me, but this is what we are saying. You can use the get method there to get a value from the hash map if you give it a key. So our map already has Nigeria. If we want to get the capital of Nigeria, we pass the key in, we have the value out. So that is what our hash map does. Stick around, we are still doing the basics. So if you already know the basics, that's okay, but there's still a lot of things to be covered. So the next thing we want to talk about is I'm trying to run through this slide quickly. So the next thing we want to talk about, okay, so all here, these are all examples for getting values in your hash map, how to put values and get value out. You can, this doesn't always have to be a screen, right? You could create a hash map with numbers. This could be like, maybe we could say we are putting integer in here. So we could turn this to an integer. Now this is an integer value. It means that if we put 2 here for Abuja, whenever we pass 2 here, we should get Abuja out. So, okay, so you see, so you don't always have to put screen, you put whatever data type. I'm coming, my phone. Okay, my phone was ringing, so sorry. So, this is what we are saying. This is what we are saying. We are saying you can pass whatever value you want to pass to your hash map, and whatever value, whatever data types the field you want your map to save, you can pass it in, and your map will do exactly that. So this is just what we are saying. Now, the next thing we want to focus on quickly is we can go ahead and solve some of these challenges, but we will just move right along. So, because the idea for introducing you to HashMap is to get you to solve programming problems. We don't just want you to know about HashMap, but it's to primarily shows you those things that will be essential in your interview processes. So those things that will be essential is what we will focus on. Those ones that you won't really need them. We won't talk about them a lot because you won't need them. And whenever you are learning DSA, my advice to you is once you know the data structure, try to play with it as much as possible. That way you will understand what exactly you are doing. But if you just read about it, and you don't go solve problem, you will still be lagging heavily. You'll be lagging heavily. That's the truth. No matter how many things I show you here, if you don't touch it, you don't try, you don't get error for yourself, you won't. Whenever it's time to code a hash map, you always be thinking you won't know how to do it. It's just how it works. So there are other methods. These are for putting values and getting values up. I've already introduced you to this. Now, there are other methods that we can use to get the size of the map. Useful method we can use to get the size of the map. We can get the map size. Maybe we want to do something with the map is to a certain area, we can use it. And then we can look over the keys of our hash map. And based on, maybe we want based upon a certain key, we do something. So I'm going to try to show you an example of each of these. So the first one is to just get the size of the map, right? So what we will do, we try to add more elements to this map. I'll remove this from here. If you are confused anywhere along the class, you can stop me and then ask me a question. I will pause what I'm doing and try to answer your question. So I'm going to put more value in. I'm going to stick with my screen. So this is Nigeria. Nigeria. It's my country, so I try to make it fast. Italian, Rwanda. Okay. So now we have put 3, and now what we can do, we can get the size of the map and say size is equal to, we're going to get country map dot size. And this will allow us to print out. What we can do here is can just pass in SAS. And then we try to see. So yeah, okay. So we have 3 elements in the map. We have 3 keys, 1, 2, 3. We have 3 items that we have put into our hash map. So as you can see here, we have three items that we have put into our hash map, and this is how you check the key of your hash map. So another one we could do, we could look through the map based upon the key. We could look through the map based upon the key, and that is just simple. So you can use this map.key set is a method you can use to move among the key of the map. So if you have a map with a lot of key, you could move through the key of the map. So, and then maybe you want to do something. If a certain key, if the map contains certain key, and then you can go ahead and do that thing. So you could do like this. Our map key is a string. So we say string key, and then we want to say country map dot key set. Now this will allow us to, what this will allow us to do, this will allow us to move, this will allow us to kind of like, this will allow us to look between the keys of the map. And then maybe if we see a specific key, we want to do something, we can do something with that key. So if we see a key, because if we, let me go back to the original slide. So the idea here is, I think I rushed. I shouldn't have showed this. I should have showed this. Okay, but you get the idea. We will get back to it. Let me just go up here and then, because I want to follow the slide. So this method here this one what this one will allow us to do, it will allow us to check if the map contains a certain key. So if the map contains a certain key, then we will be able to return maybe true or false. So let us do that quickly, and then we will get to key set. Key set will get the list of the key. So I want us to take our own time, because not all our colleagues are strong. So some of our colleagues are pretty new to these things. So what we want to do is we want to see if the map contains a certain key. So now what I will do, I will try to check if the map contains a key that I can be able to use. So I will say if country map contains key. Now I'll try to pass this key here. The key I want to pass here. So firstly, let me create a Boolean variable. Boolean. Initially, I want to set this to false. And then I'll set it to here. So I want to check if the map contains a certain key, then I will try to just set the variable to true and then do something. So I will say if the map contains a key Naija, and then what I will do, I will say system. Of course, let me initialize it. Set it equal to true. Yeah, true. And then I will say system dot out. And then I'll just pass map in here. Now, the idea is we already see we have all of these keys, but we are checking if the map contains Nigeria, and then we print we output true. So I'll clear this, and then okay. So you see, if the map contains a key Nigeria, if the map contains a key Nigeria, we can do this. So this is how you will use it to check if your map contains a specific key. Now, if your map contains that key, then you will print true. If the map doesn't contain the key, maybe we print false. Okay, so we say else. We want to set map.key to false. Now, this is important when you are trying to solve other challenging problems. You will need to use them. And if you can like figure this, if you can like get these bases right, you will have an issue. So I'll just try to put a country like United States there. I think it's been bombing Iraq these few days. So we'll pass it in. Okay, so you see we get false. So this is the idea. The idea is if the map contains a key, we return true. If the map doesn't contain that key, we return false. That is just the primary goal about the HashMap, how to use the contain key. And then I will use it before you tonight, hopefully. If I have a time, I will try and use it. This is why I want to go fast, because I want us to have some time to do other stuff. So this will return the list of all the key, my map.key set. It will give you all the key that is within that map. So what we will try to do, this will give you a list of all the keys. I haven't really used this a lot, but I will try to see if what it's talking is true. So this will give you the list of all the keys. So I'll try to run it and then see. Okay. The reason is because map doesn't exist. So these are errors that you should familiarize yourself with. Country map. Right? I'll get a console and then I'll run it again. So these are all the keys that exist in a map. And it will show a list of all the keys. So that is how you see all the keys that exist in your map. Yeah. But that is the general idea. Now, the next thing we want to talk about is because we're trying to get the basics right. The next thing we want to talk about is removing a key, right? To remove a key, whenever you want to remove a value, you just remove the key. Whenever you are trying to remove a value, what you do, you can just remove the key. It's okay, it will be removed. So what we want to do, if we want to remove, because now if you are solving one of the most familiar problems, they call that problem ARU cache. So usually, I think Netflix is the one that usually gives that problem. And you have to use a linked list and a hash map to build an ARU cache. So in doing that problem, if you don't know how to remove a key from a hash map, it will be still a problem for you. So we have to talk about this. It is very essential. So what I will do, I will remove this. And then the way we remove a key, we say map.remove country map. I'm forgetting. Instead of me saying country map and keep making this, anyway. So what I will try to do is remove Liberia. And then, okay, I remove the system start of internet first. Now I have removed the key Liberia from there. So if you run this, you see only see Rwanda in Nigeria. So this is how you remove a key from the hash map. That is how you do it. Now the next thing is to iterate over, to move over, to like look over those keys. Maybe you want to do something, right? You want to do something if a specific key exists in your map. So what you could do, you could use a for in loop, right? A for in loop. So you could say we have a screen here. This screen will be our key. Then we'll have our country map.key set. And then what we could do here is we could try and print out all of those individual keys out. And then we see. So this will give us an iterator. This is the last part. This will give us like an iterator over the key, right? This will give us an iterator over the key of the map. And we can be able to maybe pass those keys in and be able to get something out. But for now, we just want to like output those keys so we know that they are there. But this is how you will look over the keys of a hash map. We are about to discuss the time complexity and all the other stuff about hash map. So if you see here, we try moving and printing each of the keys. You see, we print Rwanda and Nigeria. The reason I didn't put a break. Let me try and okay. Now once we clear it, maybe we can put a break. But this should print each on your own. Okay. So it will print Rwanda and then it print Nigeria. So this is how you will look over the key of your hash map. So this is the idea about looking over the key of a hash map. The next thing we want to look at here is, so you have put, print, move, get, all of those things you can use them. You can, this is why I feel this whole slide with some exercises. You can try and run most of these exercises during your free time, and you will see how to do this. Because like I've always said, if you don't learn how to code and see errors, you will just not be an efficient coder. So you have to test it yourself. So I'll leave all of those ones. I'll get straight here. And here I want to ask a question before we. No, these ones they have okay, they are not really like too essential for this class. So this is. I would like to ask if you know anything about HashMap before we get to the next session. The next session, what I was trying to cover is how to avoid collision of keys and the time complexity involved in HashMap. So is there any question up to now? Anyone has a question for me? Anyone here has a question? No question? Hello, anyone here has a question? No question, and I proceed. Yeah. Okay, right. So yeah. Yeah.
Yeah. Can you hear me?
Yeah, I can hear you. I can hear you.
Okay, good evening, Mr. George. So I just want to ask a quick, clarification question. So I saw that when you were defining the hash map, right? So the data type you use is the concrete implementation. That is the map implementation, which is the hash map. So is there any reason why you didn't use the interface for the type definition? Like, is there any specific reason?
One of the reasons is this is much easier to type as one. Another one is that a lot of time in interview, people really want to understand how things look, right? You can use the interface stuff you are talking about is mainly used like when mostly you are doing a work, right? But when you are in an interview, this is how you do it. Make sense?
Okay, I know that we don't have much time, so let me not ask much question, but no problem. Just that I'm kind of confused. Why do we need to do this in the interview? Why don't we just follow the right paradigm? But no problem. We don't have much time. Yeah, thank you.
The thing is, I know what you are talking about, but most of the things that you will do in your interview is quite different from what you will. It's quite different from what you will see on the job. That is just the truth, right? In interview, you're always trying to find, like, for instance, here, I just want to clarify some of your doubts, and then we will move right along. But here is like, I don't need to fully follow the interface way of doing things. I already have a screen. I have fully showing all of my data types that will be involved, which is my key and my value. So I'm just going to keep it short because most often your interviewer really don't care for how fast your code, how fast or how efficient you type your code, how well you implement it. It's all about, can you solve the problem? I think, okay, I have a one. Yeah, I got cut off. I think it's the internet on my end. But what I'm trying to tell Brad is that in all of the cases that I have seen, it's all about how you solve the problem. It's all about, do you have the business, right? It's not about following all the time the proper channel that you need. So for me, I'm going to keep it like this. Most often even if we start to do the lead coding session, you always see me coding HashMap like this, right? Take for instance, no one really the best hash map to use in a production environment would be concurrent hash map. I haven't seen someone who use the ordinary hash map, the core hash map to do things. Mostly people use the concurrent hash map to do things, or they use tree set. But usually in coding interview we use this. To even explain it, we just use it. Simple. But that is just it. And we don't really go about doing a concrete implementation of like trying to standardize how we implement the hash map. No, it's not like that. Remember, you always have a certain number of time to work with. I will leave it like that. You can probably do your research on what I'm talking about. But is there any question?
Oh, that's clear. Thank you. It's clear.
Yeah, you can just do your research on it. If you have a lot of time on your hand to follow the interface implementation, you do it. It's okay. But for what I've experienced, I'm talking for myself. This is how I do it. I just keep it simple. Yeah. Okay. But the next thing I want to talk about will be the time complexity. Whenever you are putting an element, I've had this argument with one of my friends in competitive programming. He's a senior at Irembo. He's a senior at Irembo in Rwanda. He's do a little bit of complexity. He thought that when you are saving element in a hash map, it's always O of 1. Now, O of 1 means constant time. O of 1 means the computer don't always have to think about what you're trying to put in the hash map. But it is not true. It is not true. It is not all the time that you put an element in a hash map that it will be O of 1. So most often when we are putting element in a hash map and that hash map has position, some people tend to solve it using a linked list, and we will talk about it here. So those elements that you are inserting, sometimes because they are inserted under the hood of a linked list, Java take O of n time. It's a very critical concept, but Java take O of n time. Sometimes if you are already putting, meaning when you are doing, because there are two major threads in Java, that is virtual thread and platform thread, meaning when you are doing multi-threading. So you will realize quickly that in a concurrent hash map, Java implements it under the hood using a linked list. So you will start to see that hash map are implemented using a linked list in a node, and in concurrent hash map, it was built for concurrency. So you will start to see that maybe this is not really O of 1. Maybe what I'm experiencing here is O of n. I saw it when I was doing a specific thing for a client. I was trying to because mostly when you are doing IO bound, you use virtual thread. When you are doing CPU bound tasks is when you use platform thread, because you want the full computational power of the computer. So when I started observing, I was like, wow. And then I was experiencing a certain error called live log. I know everyone talk about their log, but no one really talk about live log in the industry. Live log is when you are trying, when a log is failing, but the log keep trying to access that data. So you will see that you start seeing that, okay, I expect this hash map to be very fast, but now it's moving slow. I don't know why. And then you start to question your background. Maybe my initial understanding about hash map was wrong. So we will talk about cohesion. If you are here about this thing. Now, I told you whenever you give a key, that key here has to a value. So take for an instance, maybe we have 9 elements in the hash map, and our hashing function is to take the key and divide by the value. So maybe we have a key, take for an instance, maybe our key was 3 letters long, and then we will divide by 9. from the hash value. So we have a key called, we call like your LRB. That's how we call it in our snacks. So we have a key LRB, and then that key get hashed to a value. So it was like, we take 3, 1, 2, 3. We take this 3, we multiply by 9, and then we point it to the value. So here is called the hash function. This is the hash function. Hash function. If you have ever done system design and you have done something called concurrent consistent hashing, you understand that this thing has a limitation. A very serious limitation that I want to tell you about today. And that is why an algorithm called consistent hashing was developed to properly hash across servers in distributed system. So what we are saying is, take for instance, we have another key that is of the same value 3. Now, if we try to take 3 and multiply, we try to take 3 and multiply by 9, we got 0. And if we try to do it in this case, we try to say, okay, 3 mod 9. We know that 3 cannot model 9, so it always gave us 0. So we say 3 mod 9, we get 0. So now we have 2 keys that are pointing to the same individual values. This is what we call cohesion. Cohesion happens when you have 2 keys with the same hash value. 2 keys, with the same hash value. So if we see here, both of these keys are generating the same hash value. So Java will get confused. What if this key is pointing to Monrovia? This key should be pointing to Monrovia. This key should. I'm coming 1 second. Let me minimize it. This key should point to Monrovia. I want to hurry up quickly. My time is almost expired. This key should point to Monrovia. Now we have a case where you now have yes. Is that a question? Yes, ask me.
Yeah, so Mr. George, it's not really a question, but just so to tell you that our time is actually up, so maybe you can round up, yeah.
Yeah, I know the time is already up. So when you have 2 keys that is pointing to the same value, you tend to solve this problem using something called a linked list. So I just want 5 more minutes, please. That's fine. I will release you by 32. I will release you by 38. 38, you can be on your way. So once you have 2 keys that are pointing to the same value, yes. So once you have 2 keys that are pointing to the same value, I'm not hearing. Who's talking?
I can't see your screen.
Can someone here? You can see my screen. Wow. Oh, don't tell me. I've been talking all of this and you can see my screen. I'm sorry for that. I'm seriously sorry. What I was saying is this. I'm very sorry. I forgot when I rejoined the meeting. I forgot to share the screen. But what I'm saying, if you have a key, and that key is pointing to a value, and now the easier way we do, if you have 9 elements if your map contains 9 elements, and what you want to do, you want to take 3 and divide by 9 as your hash function. This is what most often they do. Now, these values, these are the hashes. These hashes are attaching this key to Monrovia. Now, you have a key, you have 2 keys. Liberia have 3 divided by 9, this gave you 0. Nigeria also have 3 mod 9, this gave you 0. So you have 2 values now that are pointing to that have the same hash. So they should point to maybe Lagos. They should point to Lagos. Now, if you try to get a key, if you try to do a get to have a key, if you try to do a get to have a key, what you will experience is what you will experience here will be, you will have either Monrovia or Nigeria. you have something called a filtering value. You don't know which one to access. So to solve this problem, what usually engineers scheme away is to use something called a linked list. This is an interview question. They ask you if your hash map has a cohesion, how do you solve it? You simply say, I will use a linked list or double hashing. In a linked list, what we will do, take for instance, we have this key Liberia and we have Nigeria. We will take this value, which is Monrovia. We put another pointer to Monrovia called Liberia. And then we will take another pointer and put it to Lagos. So once you provide us with the exact value, I don't know if you know what a linked list is. A linked list is just a data structure that stores values almost in a chain. This is how a linked list is. It stores values in a chain. I don't want to talk about it too much because my time has already expired. But this is how you solve it. You just say we will use a linked list. As you go further, you will know what is a linked list. You don't have to go trying to understand linked list now. But we will use a linked list and then we will give these real capital stated to what we are doing. Another way to solve it is to use double hashing. Instead of us only using this hash value, we could double hash it. So as we hash this one, we'll rehash it again, maybe like divide by 4 here and divide by 5 here to get a unique value. The idea is always to have a unique key that will point to a value. That is what we are trying to tell you here. To have a unique key that will point to a value. So this is just what we are trying to say. Now, to get a key in a hash map is usually O of 1. But as you go further, as you have cohesion, if you have a cohesion, you will typically move towards O of n. This is what will happen because I don't want to talk about this, but let me just give you an idea. Maybe the next session, the person there will talk about it. What you will use here, because you are trying to access Lagos, you have to traverse the linked list. And in traversing the linked list, you will use O of n to try to get your key. We'll talk about that one day. These are very critical things for later lecture. To remove key is usually O of 1, but if you have cohesion, you will move towards O of n. Surely you will. So this is just I can call it maybe a quick review over HashMap. The time is always small, and then most of them I'm coming late. So this is how you solve the cohesion in a HashMap. I wish I had time for us to do all of these practices I put here, but we don't have a lot of time. So you will see how it's being done here. You will see how it's being done. But I think someone was talking about us using this standard notation to create a hash map. And I said let's use a shorthand value. But if you have any question, you can ask it, and then if not, we can close this up. Someone here got any question for me? Any question? Okay, if there is no question, I hope you enjoyed this presentation. The slides there, you can download it for further research. You can download the slide and then try to look into it. The next time I come, I'll try to review over HashMap, and then we'll try to see if we can solve some lead code problem using HashMap, so you see HashMap in action. But for now, my objective was just to give you the basics of HashMap and not to complicate things for you. That was my target today. I hope you were able to learn one or two things.
Yeah, thank you, Mr. George. Thank you for such a powerful session. Yeah, I believe we all learned a lot. For me, I actually learned a whole lot, in especially the traversing, right? Those the key sets, right? So it's something for me that I don't always use, but seeing that something like this actually exists, it's a big one for me. Yeah, I'm also sorry that we don't have much time. I wish we have a lot of time to dive deeper into it. And yeah. So since there is no question, I want to say thank you everyone for making our time to attend the session. So I believe there may be some new persons amongst us. So you are all welcome to our DSA session by the Naija Java User Group. I dropped the link to our channels. Please do well to join. If you are not part of the team yet, there's a whole lot going on. There is a lot of like this session is just one of our many sessions, right? And we have many great speakers, just like Mr. George. Yeah. So thank you everyone, and do have a great night rest. And thank you, Mr. George. Thank you very much, for bringing that time.
Okay, thank you, and I see everyone. Let's keep running.
All right. Thank you. Bye, everyone. Bye bye. Yeah.